Welcome back, my dear students. Now we will go to the next concept, that is in the module 2 only. Module 2A, that we have a compound stress. Compound stress we completed till previous class, and in the compound stress only we have another heading, a small heading, that is a theory of failures. Theory of failures, that we are going to study. Okay. See, whatever the material it might be a cylinder, or it might be a rod, or it might be any three-dimensional structure, or whatever, it might be a plate. Whenever you apply some load to that, the load again, it might be a load of tension or compression, shear, torsion, whatever the load you apply to the material, then obviously the material will fail. Yes or no? When you applied load reaches its maximum capacity, then material will fail. Okay. That failure you can measure it in different terms. Failure may be excess bending or excess twisting, or it might be a complete collapse, or it might be tearing, or it might be anything, any bent, that you can have your own definition. Or yielding, failure means when you apply some load to the material, then material will definitely fail. Okay, how to judge that failure, because of which stress that material is failed? That is because of excessive normal stress, or excessive shear stress, or which stress it is, or combination of these two resultant stress, that we don't know. And which property in the material is taking care of that failure, that not to fail, means that capacity of the material is depending on which type of strength in it, whether it is a compressive strength of the material, tensile strength of the material, shear strength of the material, or yielding strength of the material, ultimate strength of the material. Like that, a material will have their own strengths inside. When we apply load, that may fail in shear, may not fail in tension, or may fail in tension, may not fail in shear. Like that, they can have their own failure criteria. To analyze that one, we have a chapter that is called as the theory of failure. But for your UG syllabus, we are not going in deep in this theory of failure. Actually speaking, this theory of failure, we have 5 theories. First we'll name them, what all theories we have. The first one is maximum principal stress theory. This is one theory. Means here we are considering that the maximum principal stress, and we are defining this theory. And the second one is maximum shear stress theory. Maximum shear stress theory. This is the second theory. And the third one we have maximum principal strain theory. Maximum principal strain theory. Okay. And the fourth one we have maximum strain energy theory. Maximum strain energy theory. And the fifth one we have maximum distortion energy theory. Okay, we have 5 types of theories, but till now you know what is the meaning of principal stress, you know the meaning of principal shear stress. Therefore, for your syllabus, only 2 theories are introduced. Why this is not introduced? Because you don't know the meaning of principal strain, which is not taught in the 3rd semester. You don't know the meaning of strain energy, therefore it's not included in the song. This theory is not included in 3rd semester. You don't know again distortion energy, that's why this is not included in the syllabus. It doesn't mean that we can ignore this one. No, for your third semester mental that ability, for that you can digest principal stress and shear stress theory. Okay. Therefore, I will explain what is principal stress theory and shear stress theory. Okay. See here, this theory is also known as Rankine's theory. The scientist name it is Rankine theory. This is because the scientist Rankine who proposed this theory, therefore it is called as Rankine's theory. Okay. This theory states that material in a complex state of stress fails when the minimum principal stress in it reaches the value of stress at elastic limit in simple tension. Now, meaning the definition is there in your this one. What notes it is there, the definition that you can go through. Here what it indicates is, if any member is subjected to tension, or in this direction or in this direction or both the direction. When the member is subjected to tension with some shear also, there might be some shear also. When they subject tension and shear, then there will be complex state of stress will induce. Complex state of stress will induce in the body. It becomes very complex or complicated or compounded. You know? In this one, this material will fail only when the maximum principal stress becomes greater than yield strength or elastic strength. Okay, elastic strength. Again, understand, any material, if you are considering that every material what you consider, they will have their own elastic strength. Like that I am having my own strength, like that the material will have their own strength, that is called as elastic strength. And for that material you are applying various loads. Because of these loads, inside sigma 1 will develop. This resistance will develop. See, for example, I am handling some load on my head. My capacity is 10 kg. I can bear 10 kg on my head. That is my capacity. Then if you apply external load more than 10 kg, then I fail. Like that, material will have its own strength, that is called as elastic strength. And if your combination of loads which you applied, that if you calculate sigma 1 and sigma 1 is greater than sigma E, then material will fail. Then material not to fail, what you need to do? The material should not fail, right? If you are a very good designer, then material should not fail. For that, what you need to do is, you need to apply that normal stress, that is sigma 1, always less than sigma E. Or if you want to derive if you want to design that one a diameter or some dimensions, then you can consider sigma 1 is equal to sigma E and get the dimensions. If you want to checking the safety, then for a safety purpose, sigma 1 should be always greater than sigma E. This you should know. Okay, for a design purpose, I can consider sigma 1 is equal to sigma E. You already know the equation. Sigma 1 is what? This is sigma x plus sigma y by 2, plus minus is not there, only plus sigma x minus sigma y by 2 whole square plus 2xy square. Okay, this is sigma 1 you will get, and after that sigma 1 and sigma E you compare. Okay, this is maximum principal stress theory. Now we will go to maximum shear stress theory. This is called as Coulomb's theory. Maximum shear, we'll take a next slide. Maximum shear stress theory. Maximum shear stress theory. This is also called as Coulomb's, Coulomb, Coulomb's theory. Coulomb is a scientist name, and who invented this maximum stress shear stress theory. What Coulomb says is, if a material is there, then if you apply some stresses on that, inside there will be maximum shear stress developed. This is because of external load. What will develop? Maximum shear stress will develop. Inside, maximum shear stress will develop. But material will have its own shear strength. Okay, that shear strength I cannot get the material because I don't know the shear strength of the material. I always know the elastic strength of the material. In previous slide also we considered elastic strength. No? Like that, we never know shear strength of the material. If we know elastic strength of the material, that we will consider shear strength is equal to elastic strength divided by 2. This we are going to consider. Okay, why we have to consider sigma E by 2? That you have to think, because we already explained it in the previous classes, that you need to think. Then shear stress will be equal to sigma E by 2. Then whatever the toe max you are getting by application of external forces, that you need to equal to sigma E by 2. Then you can design the other dimensions, or otherwise you can check your stability of the material. Okay, strength of the material. Like that, here toe max equation we know that toe max equal to square root of sigma x plus sigma x minus sigma y by 2 whole square plus 2 square. Okay, this must be less than or equal to sigma E by 2. This is a maximum shear stress theory. Over. Now we will solve one problem so that this concepts end here. Okay, just I go on dictating that problem. You can pause the video and write the problem statement, because I did not add here, that I did not type here. See the problem 1. A bolt is subjected to an axial pull of 12 kilonewton together with the transverse shear force of shear force of 6 kilonewton. Determine the diameter of the bolt. By using maximum principal stress theory. Second one, maximum shear stress theory. Understood? We can pause it, or otherwise go back, rewind this one and write down the problem. And elastic limit is given, that you can call it as a sigma E. Elastic limit is given as a 300 MPa, and factor of safety is given 3, and Poisson's ratio mu is given 0.3 if required. If you want, then Poisson's ratio is also given. These data are given and you need to solve the problem. Once again I read it. A bolt is subjected to an axial pull of 12 kilonewton together with a transverse shear force of 6 kilonewton. Determine the diameter of the bolt by using maximum principal stress theory and maximum shear stress theory. Take elastic limit is 300 MPa, factor of safety 3, and mu equal to 0.3 if required. Okay. Now how to solve this problem? This problem is very simple problem. Before that you should know what is stresses, because here the 12 kilonewton and 6 kilonewton what that load is given, they are loads, not stresses. Okay, therefore we need to first convert stress. Okay, that normal stress will be equal to normal force divided by area, and normal force is how much? 12 kilonewton, that is 12 into 10 raised to 3 Newton, and pi by 4 into d square, Diameter I don't know, therefore I will keep it like this, and this will work out as 48 into 10 raised to 3 divided by pi d square. Pi d square is what? This is your normal stress in x direction, because they said that in the problem a bar is there like this and that bar is pulled like this. That bar is pulled like this, and this pulling force is 12 kilonewton, and this is the 12 kilonewton. This is the cross sectional area. Force by area we did, and we got sigma x. And after that, transverse shear force, they said transverse shear force is given, that you can call as a toe. And toe, you always remember that for circular diameter bar, toe max, sorry, you can consider toe equal to 4 by 3 times toe average, and for rectangular bar, then toe equal to 3 by 2 times toe average. But in this problem it is given toe for circular section, therefore it is 4 by 3 and toe average. 4 by 3 toe average means shear force divided by area, that is a 4 by 3, and shear force is how much? 6 kilonewton. 6 into 10 raised to 3 become Newton, divided by area pi by 4 d square. This works out to be, that is 32 into 10 raised to 3 by pi d square. This is the toe value. You got sigma x value and you got toe value. Then we'll go to the first method, that answer from the first method, that is maximum principal stress theory. And there you know the principal stress will be equal to formula sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 whole square plus 2 square. Okay. Here what all things are given, that you substitute. Sigma y is not given, and the rest all things are given. That if substitute 24 into 10 raised to 3 divided by pi d square plus square root of 24 into 10 raised to 3 divided by pi d square plus this whole square plus 32 into 10 raised to 3 divided by pi d square to the whole square. If you simplify this one, you will get sigma 1 equal to, check it, 20371.83 divided by d square. But this theory says that sigma 1 must be equal to sigma e, and sigma 1 is 20371.83 divided by d square is equal to, that is equal to that stress is how much given? 300 MPa. No, it is not 300 MPa. I think this is 100 MPa it is given. No problem, you can do it. Say take the same problem only. Okay. This is equal to 100 MPa to 300 MPa. Oh, sorry. This is the 300 MPa only, but 300 MPa it is the strength is given. Okay, now, but we need to do what? We need to apply factor of safety, means divided by 3. If we do underestimate the strength, 300 is given, but with the factor of safety I will divide it and I will get a, this is 100. Then what I will get? That diameter I am getting 14.273 mm. This is the diameter I got it by tensile method. And the same thing, shear stress method, maximum shear stress method, if you do, toe max, toe 1 equal to, that is square root of sigma x minus sigma y by 2 whole square plus toe square. This sigma y is not there, therefore sigma x you already know, toe you already know. If you substitute, you will get here 12732.41 divided by d square you will get. This is a toe, and a toe is equal to sigma e by 3, therefore sigma e is how much? Sigma e by 2, sorry, and sigma e is how much? 300. Factor of safety 3 divided by 2, then you will get here 50. Then if you substitute 50 equal to 12732.4 divided by d square, then d equal to, you will get 15.95 okay mm. Okay, out of these two you consider the bigger diameter. okay, which is that 15.95 you can consider